This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google Ivy Panda Free Essays.
Science can be regarded as an everlasting research of every universe aspect. People have been working out various theories since prehistoric times. It may seem that there can be only one truth, so only one theory has the right to exist. However, Kuhn explains the abundance of various theories by the peculiarity of people's perceptions. Thus, without explicit and definite facts, people describe and interpret the same phenomena in different ways. The theories were later developed into paradigms, which became the basis of numerous studies and further research. The development of a paradigm is quite a lasting and complicated process. It includes facts accumulation and interpretation and implementation of various experiments justifying the paradigm. As mentioned above, people often explain the same phenomena differently, so many paradigms emerge. Nevertheless, only a few of them become more successful, accepted by the majority, than many others. Kuhn gives a simple explanation of paradigm success by defining it as a promise of success discoverable in selected and still incomplete examples. In other words, the successful paradigm is a scope of theories and facts that can be proved within some limited field. These paradigms usually suggest that there are specific facts, gaps in the theories, that cannot be proved because they pertain to another field of science, or these gaps are not worth proving at all. These imperfections of paradigms can be regarded as dark sides of knowledge which do not deserve attention. However, these gaps are, on the contrary, the most extraordinary stimuli for further development. For instance, many scientists trying to fill in the gap often open up new horizons for science, developing new, more complete paradigms. Kuhn claims that these discoveries bring some subtle changes or even can become revolutionary. There are many examples of such scientific revolutions. One of the brightest examples of revolutionary discovery is the development of the heliocentric paradigm by Copernicus. Many non-scientists assumed that Copernicus's heliocentric theory is innovative. However, Copernicus's discovery was based on the knowledge accumulated by Aristotle and other ancient thinkers. The development of the entire heliocentrism can be regarded as a conventional illustration of Kuhn's paradigm theory. Aristotle's paradigm of the place of the Earth and other planets was closely connected with their motion and their orbits. However, this paradigm was mathematically imperfect, containing many discrepancies and many gaps. Thus, Aristotle depicted the planets' orbits and portrayed their motion in the universe, focusing on logic more than pure mathematics. Aristotle logically proved that the Earth must be in the center due to particular facts and observations. Nevertheless, his paradigm was not based on substantial mathematical calculations. This was a stimulus to fill in the gap in the paradigm which was generally accepted in the Middle Ages. Copernicus filled in the gap in the successful paradigm and developed a new one based on more thorough research. Copernicus did not try to show that the heliostatic hypothesis was mathematically absurd. Copernicus studied many theories, which enabled him to notice the discrepancies in Aristotle's paradigm. For instance, Copernicus focused on the mathematical calculations rather than accepted theory. The great astronomer was not going to refute the universal truth at that time. Heliocentrism was regarded as the only true model of the universe, which coincided with the medieval worldview. In fact, he was trying to fill in the gap. He calculated that Aristotle's model is incorrect since the orbits of planets located in that way would intersect. Copernicus continued his research and developed a new model of the universe, which contradicted Aristotle's paradigm since the Earth was not the center but one of the planets moving around the Sun. Of course, his new paradigm was not generally accepted since it opposed the core principle of Aristotle's paradigm, that the Earth was the center of the universe, which was suitable for the Church and agreed with the medieval worldview. However, later additional facts enabled other scientists to prove the correctness of Copernicus's paradigm. Regarding the development of Copernicus's paradigm in terms of Kuhn's theory, it's possible to point out that, like any other new paradigm, it was based on the old one to a great extent, so it had a lot in common. For instance, both paradigms, Aristotle's geostatic universe and Copernicus's heliostatic universe, shared the same assumption that the planets were moving around one object. Thus, Aristotle regarded all heavenly objects as material objects characterized by motion. The planets, according to Aristotle, had their definite orbits. As far as Copernicus's paradigm is concerned, the planets were also moving in a particular order, having their own orbits. The major difference was in calculations and the order of planets. Aristotle placed the Earth in the center with other planets, and the Sun moving around it. Whereas Copernicus calculated that the Earth could not be the center since the orbits of the planets would intersect. Thus, Copernicus agreed with the core principle of Aristotle's paradigm about planetary motion, but noticed certain gaps and uncertainties in the generally accepted theory. This fits the theory of the development of new paradigms and the development of science. Copernicus would not assume that the Earth was the center of the universe and would not have developed the model of the universe that is generally accepted and proven nowadays if he did not have the necessary knowledge about the motion of the planets and the existence of such phenomenon as the planet's orbit. On balance, it is possible to conclude that the development of Copernicus's theory of a heliocentric universe became possible due to the conflict of the core paradigms of Copernicus and Aristotle. Copernicus researched discrepancies in the existing generally accepted paradigm, Aristotle's geocentric universe. Copernicus took into account many other theories, facts, and assumptions. Basically, the background of his revolutionary paradigm was the old one. Copernicus admitted that the planets move, but calculated that they had other positions in the universe. Thus, the imperfection of Aristotle's paradigm, its mathematical incompleteness, became the reason for further research, which resulted in Copernicus's heliocentric theory. On a final note, it is necessary to point out that this is the conventional example of the development of science considered by Kuhn. The theories form new paradigms, which lead to new facts and assumptions. Fortunately, people notice imperfections in others' work and are eager to correct the mistakes and fill in the gaps. This is the universal rule of development. People reveal new facets of something which is already known. This essay on conflict between Aristotle and Copernicus was written and submitted by a student just like you. The IvyPanda Samples database hosts thousands of works similar to this one on various subjects. Visit ivypanda.com to find what you are looking for.